All right, so we are a couple of minutes past the hour, so as promised, we'll get started. But before I get started, I just want to kind of get an understanding of the level of knowledge that people might have of 51, because I'll kind of tailor which direction I end up taking some of the content we discussed today. If you are a experienced 51 user, like you've been using it and you're quite familiar with it, drop a 51 in the chat. If you're brand new to 51 and you've not used 51 before, drop a 50 in the chat. Uh, if you do respond to anything, please respond to this one. So again, drop a 51 if you're got experience using 51. And if you do not know anything about 51, haven't used it before, drop a 50. All right, cool. So just based on gauging the responses that are coming in right now, seems like a lot of people are new to 51. Hey, that's awesome. That's great. I'd also recommend 25.5. All right. I'd also recommend uh checking out our like getting started with 51 workshop. That'll be a good kind of deep dive for what it is that 51 is all about. Today I'm just going to cover one aspect of 51. This aspect is the plugins. Had there been more experienced 51 users, I think I would have taken the content more into how to develop plugins and how to build plugins out. Although I'll cover that at a high level and maybe help you form a mental model about what the plugin framework is like. I don't think we'll jump too deep into that. Rather, what we'll spend our time in today is just kind of what plugins are, how they work, and how you can get started using them. So hopefully that is a-okay with you guys. So let's go ahead and get started, folks. So a couple of housekeeping notes. Jim already had covered all this at the top of the hour. But yeah, session is recorded, as you can tell. There's not like a certification or anything for attending the workshop, but if for whatever reason you need like a proof of attendance, just respond to the email with the resources that we send you, and we'll get you that proof of attendance. There is a chat, of course, running here. But I ask that you actually, if you have questions, just drop them in the Q&A widget. You should see that at the bottom of your screen. If you don't see it at the bottom of the screen, look to the far right of that little toolbar with three dots, and it'll say Q&A. Just drop your Q&As there. And let's go ahead and get started. So just real quick, just to make sure everybody knows that whether or not they're in the right place. I designed this workshop and the content, just making the reasonable assumption that you already know what 51 is and you're looking to become a power user. As I mentioned, if you're absolutely brand new to 51, you can definitely stay in the session. You'll likely benefit tremendously if you go through our Getting Started workshop as well. So I recommend attending that next workshop and spend a week or so hacking around 51, join the Discord community, ask questions, and kind of get up to speed on that. I also recommend checking out a course that I've created on Coursera, which I'm sure Jim will drop the link to. This course is it's called Hands-on Data-Centric Visual AI, and it's part kind of theory and conceptual, and then part coding. So 50-50 mix between like kind of what data-centric AI, visual AI means, kind of through the lens of object detection, and then how to take what we discuss and apply that using 51. So we'll drop a link to that as well. There's another ton of great resources. We've been revamping our docs and getting started experiences. I'm happy to share the work in progress with that as well. So definitely check that out as well. So let's go ahead and real quick, just talk about the agenda. We'll do an overview of the plugins ecosystem. We'll talk about installing and using plugins. High level overview of what the framework is for plugins. We're not going to actually develop a plugin now, just given the the fact that most of you guys are kind of newish to 51. But instead, what I'll do is, we'll look through a few code examples, and I'll try to help you build a mental model for what a plugin is and how it works. I'm Harpreet Sahota, by the way. Hacker in residence here at Voxel 51. My background is math, statistics, coding. I've worked in, this is, I think, year 13 or 12 post grad school. But I've worked as an actuary, biostatistician, data scientist before kind of moving more into deep learning over the last, I think at this point, 4 years or something like that. I've worked at several, this kind of space that we're in is called developer tools. I've worked at of course, Fox 51 for a little over a year now. Prior to this, I was at a company called Deci AI, where we did mostly language models, diffusion models, and computer vision stuff. That was acquired by NVIDIA. I've also worked at some kind of more MLOpsy, like more kind of standard MLOpsy type of places like Comet and Pachyderm as well. And I guess 51 more or less kind of potentially might fit into the MLOps kind of bucket, but I think it's really more than that. It's beyond that. So yeah, that's a little bit about me. If you're wondering about Voxel 51, so we are the lead maintainers of the open source library 51. All you gotta do is pip install 51, and you are off to the races, and you're getting started. People always ask, like, what does Voxel 51 name? What does that name come from? So Voxel is like the volumetric element of a pixel, right? So it's kind of like the the space-time volume of video. 51, I mean, man, you ask the founders, they might give you this like, oh, we're 51, we're trying to list ideas, Area 51, whatever. But I'm convinced this because they had like 50 bad ideas before this one really good idea. So that's my take on that. So enough about me, enough about Vox 51. Let's talk about plugins. Does anybody here know what a plugin is? Drop a one-liner in the chat if you know what a plugin is, or try to give me a definition of what a plugin is. Let me know. Let me know. I'll wait a few seconds while I sip some coffee to see what the responses are like. All I need is one response. There we go. There we go. A plugin is something that can be plugged in. Yes. All right. Cool. That's good. Yes, Jimmy is right. With a plugin, you can add new functionality. That's right. Plugins extend functionality. So they're just software components that are going to extend the functionality of an existing software application without modifying its core code, which is great because that means that you can hack around and do stuff and build without actually kind of ruining anything, more or less. But in the context of like an open source library like 51, they serve several key purposes. So plugin, they're dynamic add-ons. So they'll help you extend what you could do with 51. And they're more or less like building blocks. You snap them in when you need a new feature, you remove them when you don't. And they're independent, really. That's what makes them special. So they're kind of standalone modules. And in our case, for 51, they follow a integration guideline, which we'll kind of cover in a few minutes. But you can install, update, or remove a plugin without really touching 51's core code or disrupting anything else that you do with the library. And so this makes it more versatile, and it really encourages community collaboration because users are then able to create and share plugins that solve specific problems, right? So again, like, you can not use plugins, or you can, kind of sit there and watch everybody having fun, making the workflow spectacular while using plugins. So again, I encourage you guys, to, as you progress along in your 51 journey, as you learn more about plugins, as you learn more about the library and learn more about what is possible with the library, I encourage you to kind of create and share plugins and then make them open source and then share them with the community. So question here, is there a plugin that will help use Gen AI to examine each image and then add image content descriptions to image file name, or insert descriptions into XIF metadata within the JPEG file? Currently, well, let me say this. So partially yes or no. Like the second part of your question is very hyper specific. And for that part where we are adding descriptions to file names or inserting descriptions into metadata, nothing like that exists yet, but it could exist if you build it. And if you build it, and if you're thinking about it, that means other people might want it. And if you build it, I will help you, and we'll make it open source, and we should share it and use it with the community. The other aspect of that, Gen AI, we'll see a little bit of Gen AI plugins, but for using Gen AI models now, we're kind of, kind of getting ahead of myself here, but it used to be the pattern that if we were to integrate like a new model into 51, we'd use a plugin. But now we have essentially what's called a remote source zoom model. And I'm digressing here just a little bit, but I'm going to pull up my GitHub and I'll drop a link here to the chat. But you can use several like for example, we have Polygemma, Kimi, Quinn 2.5, Moondream 2, and Florence 2. These are all kind of vision language models that you can easily run, in 51. You could see here, it's just a couple lines of code to get started. So we're not going to cover these too much in depth here. But yes, to answer your question, you can do that. Sorry for the digression. What I'm going to do now is just drop a link to one of my GitHub repos, and I encourage you guys to just kind of look through my repos and find the other ones. But yeah, I'm hyped on VLMs and Gen AI. That stuff is interesting and fun, and we're bringing more and more of that to 51, specifically, now and over the next several months. That being said, let's go back to plugins and what they do. So plugins, they make it easy for you to do your thing, right? It will help you save time by turning that complex or tedious task into more of a point and click operation. Um, you can focus on the data and not have to dig through old scripts or kind of, try to remember code snippets that you've used previously, and just really focus on digging into your data. Because if you're able to understand your data better, you're able to find data quality issues, you'll train better models and deliver value faster. And I'm sure you guys are curious. Okay, you know what plugins are, you kind of understand what they do. What are some examples of plugins that are out there? So what I'm going to do now over the next several slides is just show you the various plugins that we have. And then after this, we'll kind of talk about the framework of the plugin, and then we'll see some in action. So a little bit of prep for what's to come. So one example of a plugin that we have, a really basic plugin, is called the utils plugin. And this just is essentially data management operations that you can perform directly in the app. So you can create, load, clone, delete data sets. You could edit data sets, metadata. You can rename data sets, delete samples, and things like that. So it's basically everything that you could do with the 51 SDK, but with the nice UI and point and click operations. Another example of a plugin that we have is the model evaluation plugin. And this is, again, of course, you could do all this in the SDK, but right here in the app, you can point and click and get stuff done. And so again, it's a GUI wrapper around 51's evaluation methods, and it makes it easy for you to kind of assess your model's performance directly in the app without necessarily having to write code. There's this IO plugin, which we'll see in a little bit, but it's helps you import and export samples into a data set and out of a data set. And again, a GUI wrapper around the functionality in the SDK. And so this is useful if you want to import new data, merge data sets, export annotated samples, things like that. And we'll definitely see this in action in a few minutes here. 51 also has this very robust kind of what we call the zoo ecosystem. So there's a data set zoo and a model zoo. And so this plugin will make it easy for you to access our pre-built data sets without writing any code. So you can download and load data sets from the 51 dataset zoo. You can configure the different splits of a data set, and you can even run and download and run models from the official 51 model zoo as well. And another plugin, or this is kind of more of a panel, but it falls within the plugin ecosystem here. And this one I really like a lot. This is the dashboard plugin. So this really helps you get a high-level overview and understanding of like what is in your actual data set. So, instead of having to write code and, write code to build histograms and, bar charts and things like that, point and click, easy to do. And it's right there, and it's interactive as well. So as you click into one element of a chart, it'll filter down to the samples that are kind of in that element. And we'll see this in action as well. But it's nice. It's just a visualization tool that really helps you monitor and analyze the characteristics of your data set. And you can customize this dashboard. And once you have a dashboard customized, you can save that dashboard, that view rather, so you don't have to keep on like recreating it. So anytime you get new data, it'll dynamically kind of update. And beyond that, kind of some, everything we've covered so far, I think is kind of, I want to say, table stakes for what you would expect for a tool that helps you explore and understand data sets. The next several plugins I'm going to show you, these are kind of more extend the functionality of 51. One of them I really like here is a PDF loader plugin. So in 51, like the core thing in 51 is you have to work with like visual medium, whether that's like a image or a video or 3D. Uh, but what this plugin allows you to do is actually you can point to a directory full of PDFs and you can load those PDFs into images. And this is nice because you can then do some other interesting things with that uh, data that's loaded in. For example, sorry, just to digress again, going back to my GitHub here, I recently created a visual document retrieval. This is actually a remote source zoo model that allows you to, look at the document, create embeddings from that document, and then you can do semantic search with a text query and the contents of what is in that PDF page. So that's quite useful and helpful. Another thing you might want to do once you've got your PDFs loaded is actually do some OCR. And so for that, there's actually a plugin that I built here somewhere. It was the Nemo Retriever Parse plugin, which requires you to have an NVIDIA API key. But once you got that done, you'll get some really clean detections around the different text elements in your PDFs. So yeah, I mean, there's so much you can do with plugins. Once you've done like kind of that extraction that I just showed you, for example, we did if you run that NVIDIA Nemo parse plugin, you'll end up with a field on each sample that is the text. Then if you want to do just a keyword search over that text, you can use our natural language search plugin. And you can even do more interesting and cool things. For example, here's a plugin that allows you to create an AI art gallery. And so what you'll do is, you pick your image generation model, add in a prompt, whatever kind of parameters to make that model run, and then add that sample directly to your data set. Another thing you could do is, reverse image search. This is an interesting plugin. If you've got like let's say you're working with autonomous vehicles or a data set full of like images of street views and things like that. You might get some new data that comes in and you might find some anomalous data point. What you could do is then take that anomalous data point and do a reverse image search to find if there are other images like that anomalous data point already in your data set. And if there aren't, then you know that, okay, well, I need to go and collect more data of this type. So really, the art of the possible with plugins is limitless. For example, here's an interesting plugin. And this plugin is actually built on the image bind model. And what this plugin allows you to do is actually use the image bind model to do cross-modal search. In this case, what we're going to do is drop in a sound clip of a train and then find all the images in our data set that make that sound. So that's quite interesting. I mean, the list goes on. There's so many plugins. There's plugins. If you can imagine it, if it's something, if you can imagine it and if you can code it, you can build a plugin for it. It just keeps going, right? This list will keep on growing. Whatever the use case or workflow is, if you can code it, you can turn it into a plugin. Questions here. Okay, does it also display the confidence of the search? That particular one, I don't think that plugin has confidence in there, but I mean, you can definitely code the plugin to do that. What if the retrieval doesn't work? That's more of a model issue and less of a 51 app issue. So that's, the retrieval doesn't work. It's an issue with, I would say, the model in that case. But just going on here. So how do we use a plugin? It's a few simple steps. Step one, just browse through some of the plugins in our plugin repo. So drop in a link to that into the chat right here. The plugin is using a model. Yeah. So some plugins do use models for sure. Under the hood, some plugins might connect to an API. Really, more and more we use when it comes to actual models that are not behind an API that are run more or less locally. Those models actually we move to a pattern now that's called a remote source zoo model. but mostly, yeah, like they're using models in the back, and they don't necessarily have to. It's not a required condition. Um, but yeah, step one, browse through plugins. Uh, if you see a plugin in there, be sure to star it, watch it, because that list is getting constantly updated. Once you've seen a plugin that you like, what you're going to do is visit the repo for that plugin of interest, take a look at the README, and once you're ready, all you got to do is follow the instructions on the README, which typically looks something like this: 51 plugins download, and then the plugin's name. So that's basically what you got to do to download the plugin. Once you've downloaded the plugin, you can, or rather, that the command I just showed you, CLI. Alternatively, you can do it via Python if you want to download a plugin via Python. You have the ability to do that as well. Um, Once you've got the plugin loaded, import a data set. I apologize, these GIFs keep running. I should have made them one loop and stopped. But yeah, once you get the plugin installed, get a data set. What you're going to do is launch the app. So once the app is launched, which you can do, 51 app launch in the terminal, it'll launch the app. You can hit the backtick button. When you hit the backtick button, it'll open up the browser menu, or within the app itself, you can look for this icon. As you can see here, that's that icon right there. You click on that and you can browse through all of the plugins that you have installed. Then what you're going to do is click on the plugin that you want to use and fill out the form. Alternatively, you can use a plugin via an API as well. So, we'll focus more on the app here, but you can use a plugin via the SDK as well. And then all you got to do is just wait. Sit back and relax, let the plugin execute, let the thing run, and you'll have results on your data set. And we'll see all this in action in just a few minutes here. But real quick, just how does all this work? Well, the core to 51 plugins is this concept of an operator. So the operator is what allows you to essentially execute a plugin. And it's essentially, in coding term, it's a generator. And what you could do is also delegate an operation with an orchestrator. So if you have our enterprise version, 51 Enterprise, for example, you can delegate the execution of a plugin to like a cluster. If you've got like a cluster of GPUs, you can execute it there. On the open source end, if you delegate the operation, we just treat your one computer as a node and execute there. And the operators have input and output. There's execution, there's placement, there's configurations, and then there's delegation. So again, at a high level, we have a operator that has some configuration with it. That configuration requires some context, and what that context is comprised of is placement. Placement meaning, when we're looking at the app, where in that app view do we place the elements of the form? There's also the input. So what is required for this plugin to do its thing? There's also the output. Once the plugin does its thing, what is the output that we get? There's also execution. This is where you define logic for what the actual execution is like on the input that we have. And then delegation, as I just mentioned, this is all about kind of using compute resources, more or less. So real quickly, this anatomy of a plugin looks something like this. So there's really two main elements. There's the Python operators, and this handles and runs all kind of like the machine learning stuff. And then there's JavaScript for the UI. You don't need to actually know any JavaScript at all to build a plugin and to build a UI. And this kind of line that I drew here is not always cut and dry. So there's interactivity in Python, and logic and computations from JavaScript that we kind of map to Python. But broadly speaking, this kind of anatomy here is how we think about it. You can write a plugin really entirely in Python, entirely in JavaScript, or some combination of both. Because under the hood with 51, There's communication between Python and JavaScript. We're going to focus primarily on Python plugins when we look at code because, well, that's really the only thing I know how to code in. So more or less, the anatomy of a plugin looks something like this. So we have some required kind of files that we need for a plugin. One is the 51.yaml, which declares a plugin. Next is the dunder init, which is going to define and register all the operators. There's the requirements.text, which we have as optional, but really you should, I think it's more required. Then there's kind of helper functions that you could have, and as well as a README that will document everything. And the 51 YAML looks something like this. We'll look at a few examples a bit later on, but just kind of give you a mental model of it. For 51 YAML, we have to declare some things. The name of the plugin, the author, the version, the URL where that plugin is housed on GitHub, what operators that plugin exposes. And, if you have plugins that require some secrets, then what are your secrets? You can list them there as well. Then this concept of an operator looks something like this. So it's a user-facing kind of class method that allows interaction with the data in your data set. What the operator can do is it could accept a parameter via inputs, forms, and properties, and it'll execute those actions based on those inputs. And then it could optionally return an output. These operators can be simple. They could, just be checkboxes or more complex workflows like, requesting annotations from a, backend, for example. You can do this directly. They can be executed rather directly in the app. They can be triggered by other operators. You can use this in the SDK. But essentially, this thing that I'm showing you right here, this is just the building blocks that will help you create more complex workflows. So, given the fact that most folks here are newer to 51, I'm going to gloss over the code stuff just a little bit, and because I really want to get right into the plugins. This what I'm showing you right here is kind of the operator configuration. We'll link to docs and stuff, but I think it'll be more beneficial for us to kind of just see some plugins in action. So I'll gloss over this. The point I want to make is that you can easily build and ship your first plugin in an afternoon if you'd like. What exactly do I mean by that? I'll give you some hints here. This is how I would approach it if I were you, just to get started with plugins, right? I did mention that we're kind of moving more towards remote source zoo models, but if you are interested in getting your reps in with a plugin, I think this workflow is a really easy way to get started. You can find a model that you like on Hugging Face, hack around with that model, write some code to apply that to your 51 data set, make that code more modular, and then you're going to follow a format that we require. This format is going to be something like this. We'll have to write some code, submit the code, put it on GitHub, submit it to the 51 plugins repo, and you'll be off and running. And like I mentioned, we're going to look at some code samples at a high level in just a few minutes. But what I want to do next is actually just jump into plugins and show you kind of how everything works. So what we're going to do is high level 51 plugin usage. We are going to use what's called the IO plugin to load data from disk. We'll make use of the utils plugin to handle some basic stuff. We'll compute some image quality metrics, and then we'll look at the dashboard. We'll compute some embeddings. We'll run some zero-shot prediction, and then we're going to look at the results of that zero-shot prediction using the evaluation plugin. So real quick, the first thing we want to make sure is that we got our ports forwarded, localhost 5151. I see something coming into the chat here. Nope. And when we start with the plugin, what we want to do is first export this environment variable here. This is for open source. We start by exporting this environment variable. If you have the enterprise version, you don't need to worry about that. Or you can also just set it in the Python environment. I'm just going to restart this just to clear stuff out. And so run this. And like I mentioned before, downloading a plugin, you can do it straight in the terminal or via SDK. So here I am running a terminal command here to download some plugins from this repo. So we have this 51 plugins repo, and I'm downloading these different plugins. So simple line of code to do that. We'll make use of the Hugging Face plugins to push a data set to Hugging Face. And that's, again, same pattern. You can make use of some community plugins in this session as well. So for example, we'll make use of the image quality issues plugin. We'll make use of we'll make use of zero shot prediction plugin. Why not? We'll use the AIM embeddings plugin. And for any plugin that has a requirements, you need to follow this pattern to install those requirements. So 51 plugins requirements, that plugin name, and then install it. So real quick, just to pull this up, just to show you something, right? Looking at this here. So looking at this plugin, if we look at the 51 YAML for this plugin, right? So this might be the name of the repo, but the name I gave the plugin is this. And so that's why we're using this as the plugin name, right? So the repo name and the plugin name can be different. And then the operator that this plugin has is compute aim v2 embeddings, right? So we'll look at this code a little bit later. But the patterns to install plugin, straightforward, using the command line. All right, so what we're going to do now is we're going to create a empty data set, right? With this data set created, what we're going to do then is add samples to it. So I'm going to go ahead and launch the app. And I'm going to, hopefully it opens in the right browser. Let's go ahead and take this here. I'm going to move this here. Close this out. All right, cool. And so we just created an app called Wonders, right? So what I'm going to do is look at my data set drop down here. I'm going to click on Wonders. You can see here, there's no samples in this app yet. No samples in this data set yet. So what we need to do is import samples. So I hit the backtick button, hit the backtick. This opens up the operator's browser. What I'm going to do is click in import samples, right? And so the samples I want to import for this is right here, the wonders of the world. So you can see here, this follows a, if you've done computer vision classification, you might recognize this as a image classification directory tree format. So this is what our data set is structured like. What I want to do is import media and labels. The data set type is going to be an image classification directory tree. The label field that I want to store my labels in. So if you recall from an image classification directory tree, the way it works is like we get our labels from whatever folder that image is in, right? I'll go ahead and select the location. So we're in workspace and plugins workshop, wonders the world. And so it's nested. So I got to open it twice, right? So click on that and say choose. We'll just go ahead and execute this. And you can see here, I've loaded in samples into my data set. So let's go ahead and just shuffle this. So just give us an idea of what is in here. Shuffled, right? And so what we could do right off the bat is, okay, we could do filtering if we'd like. We can click on this and filter and do that type of stuff. We can create a dashboard right off the bat here. I'm going to create a dashboard. I'm going to do a categorical histogram. And we'll call this frequency, class frequency. we'll do the ground truth label, sort by frequency. Then we'll create the plot. And so you can see these are interactive, right? So I could see, uh, all those plots here. So that allows me to do that. We can clear off each stage here, right? So as I click here, if I want to clear out this view, all I got to do is hit an X on that, clear out, and everything will reset. So right off the bat, we're able to look at our data, look at the distribution of labels, and kind of get a sense of what is in the data set. That's cool. Level 1 is quite interesting, but we could do more with plugins. So what I want to do now is we've exported this environment variable. We've launched the app. What I want to do now is actually sorry, one second. All right, what I want to do now is actually kick off a delegated service. So delegated service is essentially going to treat, I don't know if you guys could see that GPU machine back there. Maybe you can. It goes back there somewhere. I'm going to treat that as my compute node because that's where I'm running the app at. And the delegated execution is going to allow us to kind of keep track of, what the app is. What the execution on the samples, and then also allows to continue to interact with the app. So what I'll do is I'll do 51 delegated launch, kick off a delegated service. Great. So now what I'm gonna do, I'm just gonna we'll close this out for now. How about we'll close this out for now. We can now do some image quality analysis. So we can, for example, do using the image quality issues plugin. Let's say I want to compute blurriness. If I click on delegate execution and I hit schedule, and then I go back to my terminal here, you can see that I've got like progress, and I can get all the warnings and errors and all that stuff. I could run it as like not a delegated service, but then you don't see all this stuff under the hood unless you implement a operator for progress. But we can see here everything that's happening under the hood, and then right off the bat, we'll have a label field here for, after refreshing the app, for blurriness. Let's compute a couple other image quality metrics just to, image quality issues. We just did blurriness. Let's do like entropy. Maybe let's just do entropy. We'll do two more. Hit that, then I'll hit image quality issues. So we just did entropy. We've done blurriness. Maybe we can compute contrast. We'll do that. And so hit that. We see the update here. So entropy is done. Contrast is running. And so let that run just a couple of seconds more. And I'll keep an eye out at this point. So at this point, there might be some waiting while some operators run. I encourage you guys to ask questions during this time as well, because it'll be a good opportunity for me to pause and answer those questions. But we refresh the app here, and you can see that we've got blurriness, entropy, and contrast computed. We could, of course, do some filtering if we'd like. That's one way to kind of do some analysis. But we could also just open up the dashboard panel. Again, we can create a plot. We could do a numeric histogram. Let's just do blurriness. The data source will be blurriness. We'll say blurriness. We'll do, how about 200 bins? I think that's a good amount. We'll create the plot. Then I'll go down here. I'm going to add another plot. I'm just going to add plots to get a better understanding of what's in the data set. We'll do this entropy. Categorical, I need numeric. Data source will be entropy. We could do 200 bins again, create the plot. Let's add another plot. We'll add a few plots just for illustrative purposes, just to show you how interesting things can get. We'll open up contrast, not numeric histogram, it's categorical histogram. And then we'll do, sorry, it was supposed to be numeric, not categorical. Haven't had enough coffee yet. All right, contrast. Let's do 200 bins again. Maybe that's too much. Maybe let's do 50 bins. Maybe that's too little. Maybe let's do 100 bins. All right, it just seems that our data is heavily skewed that way. I don't like this layout. So what I want to do is actually let's move stuff around a little bit. Let's move this here. Let's move this there. All right, cool. And let's actually add a couple of more plots to our dashboard. Sorry. Let's add a couple more plots to the dashboard. Let's add a plot. Let's do actually a scatter plot. All right. And we'll do a scatter plot that goes, how about entropy versus contrast. We'll put entropy, put contrast on the Y. We'll put entropy on the X. Right. And let's see. Yeah, scatter plot. Right. It just looks weird like that. What happened? Looks like I was trying to do too much. All right. The demo gods, man. All right. Well, I'm not going to go through all that process of creating all those plots again. I'll just do one of them. My apologies, guys. Things happen sometimes. Let's just do entropy. Let's do the data source as entropy. All right. Let's do this. 200. All right, cool. Create the plot, whatever. I mean, you could see that, as I had just demonstrated prior to me doing getting that error, you can create any number of dashboards, any number of plots, and just for the sake of illustration, I'm going to create another categorical histogram. This will be frequency of class, and then we'll use the ground truth label by frequency, create the plot, right? So what I could do here now is, like I mentioned, this is all interactive. So just real quick, we'll shuffle all this stuff. All right, so like I mentioned, this is all interactive. I can click into one of these bins, and when I click into that bin, the class frequency actually adjusts as well, right? And so we saw that. I cancel that out. Let's say if I go to any one of these now, I can filter by, for example, pyramids of Giza, and then look at the distribution of this particular metric, in this case, entropy, for that class label, right? So interactive, plots are nice. What I'm going to do is actually I could save this as well. I could say custom dashboard. So it'll be saved, right? So now when I clear out of that, I just go here, look at custom dashboard, it'll pop up, right? You saw before how I had to like manually add everything again, one at a time. You can actually save that and have it show up just like that. All right, cool. Any questions at this point? If there's no questions at this point, I'll continue on. There's a couple other things we want to do, right? To explore data, this is one high level thing that we could do. But to get a better understanding of what is in your data set, sometimes you want to do an embeddings-based workflow. So I mentioned that I created a plugin for the Apple AIM embeddings. So if I put AIM here, and just going back, we'll use this as an example. When I look at this plugin here, right, this is the operator. If I go to the code here, I'll look at the init, scroll down here, and you can see this config, right? Let's close this out and let's actually open this side by side here. I'll hide this. And when I hit backtick, right, you can see what I'm pulling from the config, right? So the name is compute AIM v2 embeddings, and that's what we see right there. The label is compute embeddings with AIM v2 models. That's right there. The icon is this Apple icon, which is right there, right? So if I click on that, then I end up with a form that I need to fill out. This is all the input. And if we look at the code, what we are doing is, this FiftyOne app is all JavaScript, but all my code is in Python. And we can see kind of where things relate. So here we're resolving the input. So I'm going to capture all the input from the user. In this case, choose the AIM embedding model you want to use. Well, look at this. Choose the AIM embedding model you want to use, right? So that's the placement I was talking about. I want to use this model. All right. So you can see I selected from one of the models, model weight, See all that rendered right there on the app. So the embedding type is the next thing. So which embedding type do I want to use? So do I want to use class token or just or mean pooling? And you can see here, I'm just created a radio group and I added the choices that I wanted to have. Right. So this is the placement aspect that I meant. Let's just do mean pool embeddings. And then here you can see embedding field, name of the field we want to store the embeddings in, right? Let's just call this AIM embeddings, right? And then Boolean, whether I want to delegate it or not, right? So this is kind of showing you how the form that we are using to collect input from the user is now going to saturate context, right? Now you see here, this execute function. I'm going to hit execute right here, right? Everything I filled in here, right? The model name, the embedding field, the embedding type. When I hit execute, it's all going to go into this function called run embeddings model, right? Dataset equals view just means, the dataset that I'm looking at right now. But the model name, the embedding field, and the embedding type is all coming from the user. And when I hit execute, then this run embeddings model function is going to run. And then that under the hood is just everything I've defined here. Right? So I scroll all the way to the bottom here. Here's what run embedding models does, right? And this is all just logic for us to essentially this logic that's a wrapper around what was on the model card on Hugging Face. So how do I load the model? How do I load the processor? How do I go through and do the embeddings and things like that? So hopefully it's kind of like demystifying. I know I said I wasn't going to go too much into code, but I did want to illustrate that just to show you. If we go back here, we can see that the embeddings are running. Take a few seconds. AIM is quite fast, which I like. And you can see here I'm running a NVIDIA RTX 6000 ADA, and it'll take just a minute or so to go over the 3,800 samples, right? So once we have this done, we have to write a couple of lines of code because we're working in the open source. If you were to do this with the enterprise version of FiftyOne, like you wouldn't have to write this additional couple lines of code. You can with one click compute the embeddings, compute the visualization, and the similarity index. Right. So you can see here, if I go here and I look at embeddings, even though I just computed embeddings, like nothing like shows up. Here, if I do compute, visualization, I could do that in the app as well, but I first had to compute the embeddings. So to compute visualization, brain key, we could just make it up. We can call it AIM viz. The name of the embedding fields populates here. So these are the AIM embeddings. The method I want to use is UMAP. Number of dimensions, just leave it as 2. Random seed, we'll do 51. Whether we want to create a spatial index for computed points. They recommend it, so let's go ahead and do that, right? and the points field will be in aim viz. So we'll click here, go to execute, hit execute, see everything populate here while it is executing. All right. Taking, oh, there we go. Cool. It's done. So now when I click on embeddings here, oh, refresh that. Click on embeddings here, select the brain key. We can color by, where's ground truth? There you go. And we could see some separation in that embedding space too. We could do some potential, further exploration. So just looking at this cluster here, right? So looking at this cluster, this kind of dark green cluster, it says it's mostly images of the Burj Khalifa, but then we have like some that are, borderline. Looks like pyramids of Giza here. So why don't we just zoom into that? Right, these are supposed to be Burj Khalifa, but what do we end up with? What are the misclassified ones? Well, we see that Messi is misclassified as the Eiffel Tower. We got some duplicates, so that's challenging. And we could see here, okay, well, it looks like some are being misclassified because, well, we have the Burj Khalifa in actual images with the other buildings. So here's the Burj Khalifa with Eiffel Tower, with Giza pyramids, so on and so forth. And so that's probably the source of that kind of misclassification. So yeah, with this embedding based workflow, it helps you get that more kind of in-depth analysis of what's in your data set. We did actually create a similarity index, right? So one thing we could do is actually here, let's uniqueness. We can actually add a score here that'll have like a uniqueness value. How do you spell uniqueness? UNIQUE. It's written right up top, uniqueness. So the optional sample field, region of interest, we don't have that. The embeddings will be AIM embeddings. We'll go ahead here, click on execute, hit execute. I guess it's executing, but it's not delegated. So that's the reason why we didn't see here, because it wasn't a delegated operation. That being said, this hit refresh on the app, and we should see a uniqueness score here, right? So of course we can go back to our custom dashboard here. Let's go ahead and just add another plot. Let's add a plot here for a numeric histogram. Call it uniqueness. And the source as uniqueness. Whatever. We'll do a bin size of 100, right? We'll create the plot. So now what this allows us to do is, let's say, okay, we could, of course, look at kind of the most unique images in our data set globally without considering the label, and see what those most unique images look like. And actually, the most unique images tend to be from Angel Falls. That's interesting. We could also look at uniqueness score by a particular class, right? And so uniqueness is essentially, we'll drop a link to the code here, but it's just a way to measure essentially what it says, uniqueness. How different is this image from all the images in the data set? And if you get an idea of that on a per class basis, then you'll see what the most kind of weirdest or uniquest rather elements, images, samples are for that class. So for example, here we're looking at nothing but Pyramid of Giza. Then what are the most unique Pyramid of Giza images? So just, so I had clicked just one at a time, but I could do a lasso select and then select this entire range as well. So that's something you could do. You could, zoom in and out like that as well. But again, allows you to get further detail about what is in your image. And then once you've, kind of, let's just say that you look at an image and you classify it, okay, this is extremely weird, right? You can see here, it's got a very high blurriness score. It's low uniqueness, and maybe we can just add a tag here to the sample. Let's just say we'll call this maybe a low value sample, right? All right. Um, we can apply that, add this as a sample, and then later on, what we could do is as we're kind of looking at images and understanding and exploring our data set, we go through, we're tagging images as low value that we know we could exclude those from the next training run, and see what impact that has on the model that we trained downstream. Just another kind of illustration, we computed uniqueness. Uh, there's also a similarity heart. Let's do a similarity here, actually. And we'll call this a sim index. Embeddings will be aim embeddings. We'll just see the scikit-learn backend. We can just use cosine as a metric. Go here, execute. I see a question pop up in the Q&A panel. How can, 50 pip install 51. So Jimmy, if you're still around, if you could drop a link to I think maybe my workshop that I did, not workshop, Coursera course. You can take it for free, audit it for free. It's a good place to start. So definitely check that out. That Coursera course. But yeah, it's open source. So yeah, pip install 51 is all it takes. Cool. So just again, just I created like a similarity index. So what can I do with the similarity index? Well, I can, maybe let's shuffle again. All right. 51, C51. Let's say I want to do something like this. Let's say I click on this. What I could do now is sort images by similarity. Let's just say I want the 5 most similar images to this. And then I'll say show similar samples. And we could see that. So interesting ways for us to understand and figure out what is in our data set. All right, so just showing you more of the cool things that we could do. Right, so we've looked at computing image quality issues. We looked at computing embeddings, visualizing embeddings. We've looked at how to build a dashboard and things like that. Now let's make use of the zero shot prediction plugin. So just opening this up, we'll say zero shot prediction, right? Specifically, we'll do zero shot classification. We'll use a clip. We'll take my labels from a file because I don't want to type them out. Let's go here. I've got my labels here, right? We'll just call this predictions. We'll delegate execution, hit schedule. We'll look here. Nice thing about clip is that it's quite fast to run and the GPU is quite powerful. So it'll just take a few seconds. And then once this runs, we'll see that we'll have a prediction field based on the clip embeddings. Based on the clip zero shot model. So that runs. We'll see predictions here. Go ahead and refresh the index. Refresh the app. We see the predictions here, right? And, we could kind of visually vibe check the predictions, but let's do some actual evaluation. So I'll open this up and then I'll say evaluate model. The prediction fields is called predictions. The ground truth field is called ground truth. Evaluation key, let's just call it eval. The method, since we're doing classification, there's a few different methods we can use. I'll just do simple classification. We'll use the default classes from the data set and hit execute. Right. And then we can see some eval keys that we have. I'm not going to go too in depth with that. What I want to do now is actually just open up the model evaluation panel. We can see the evaluation key here. And now we're looking at the performance of the clip model versus the ground truth model. We can see here we've got the high level performance of the model, not too bad. We can look at average confidence prediction, so on and so forth. We can look at by class performance of the model and even confusion matrices. So in this case, it does pretty well. You can see there's not too many values on the off diagonal, but right here, ever so lightly, it looks like the model is confusing some Angel Falls with Machu Picchu. Why? Let's take a look at that. You can click down on that. Well, that's not supposed to happen. Well, bugs sometimes happen, I guess. uh, yeah, yeah. Typically, you're able to click into that. We just made a new release, so who knows? That might have made things a bit wonky, but you can get all this information about model performance and things like that. Um, so yeah, it's quite flexible what you could do with the plugin ecosystem. I know I went through a lot and tried to show you a lot while at the same time giving you kind of a conceptual overview of how the plugin relates to code. Because most of the people here are new to 51, I won't go too in depth with the code. I do encourage you to join in on our uh, Discord community and ask the questions there. Just real quick, one last thing I want to show you that we could do. Let's say you've gone through the work, you filtered out your data set, and you've done all that stuff. You can actually use our integration with Hugging Face to then push this data set to the Hugging Face hub. In this case, we could say wonders of world license. Just make it Apache 2. And then, we can forget about all that stuff. Preview image. I guess they want us to have a preview image. So open here, real quick, just going through here. Just pick one. Typically that preview image is like, yeah, typically that preview image is just like a GIF. Yeah. I have not logged into Hugging Face, which is why this error is happening. So yeah, you need to log into Hugging Face, of course, and you're able to push it straight to Hugging Face, which is, show you how to do that. Thought I was logged in. Okay. Anyways, it did work when I was testing all my code this morning. So I'm not sure why all of a sudden it stopped working, but hey, things happen. I think that's pretty much all I want to show. I guess something else I could probably show you guys that you might like is just to kind of show you what other cool things you could do with plugins. I've got this like depth estimation plugin that you can use, and just to kind of show you how that would work. This is a big model. It'll take a long while to execute, but we'll let it execute, and then I'll just show you some intermediate results while this is executing. And this is the nice part about a delegated operation, is because you can see the results as they are populated to your data set. If it wasn't delegated, we have to wait for the thing to execute entirely before we can even look at it, a result. But I'll hit execute here. This is using the Apple Depth Pro model, which is quite a beefy model. So it'll take a few seconds for it to load up. I'm not going to make you guys wait that long to see a result, but what I'm going to do is just show you some intermediate results, and you can see some results with the depth. So I'll refresh the app, look at depth. We can see the results from that depth estimation model. So we can make the opacity a little bit less. And you can see how that model performs for depth estimation. So yeah, that's the plugin ecosystem. This is 51 plugins. You saw how to do a lot of stuff that typically might require a ton of code. Do it right there in the app. I encourage you to try to build your own plugin. Join us in the Discord community. I'll help you build plugins. Like legit, that is like my job. So I'll help you build plugins. I'll help you integrate models, whatever it is that you want to do. If there are questions, that was a good time to ask. Is there anything that I'm missing in here?
Well, I did want to point out in the chat, I did post a link to the Getting Started workshop. So for those of you that felt this was great, but maybe needed a solider grounding on the fundamentals of 51, I just stood up the Getting Started workshop that's happening on the 18th, and the link is there. So I highly encourage you to check that out. It'll go through installation, it'll go through embeddings, it'll go through loading a data set, where everything is in the UI, all that good stuff. So if you want to build a good foundation, I highly recommend checking that out. Also, I included the link to the Discord. It's a great place to talk about 51. There's also specialized channels where people talk about medical images. There's even a channel in Spanish. So all kinds of interesting channels that'll scratch your itch. Also, it's a great place to talk about all things computer vision. We also have channels where people just talk about computer vision in general, whether it be research, whether it be models, whether it be data sets. So it's a great water cooler and gathering place to talk about all things computer vision, not just 51. And the last thing is that, as Harpreet mentioned, if you want to go at your own pace, on demand, step by step, I definitely recommend checking out his Coursera course, which not only takes on the fundamentals, but gives you excellent background on the computer vision concepts and how they're implemented, how they're realized inside of something like 51. So the Coursera course is highly encouraged to do that or to sign up for that, as it is at your own pace, and it's got code, it's got lecture, it's got video, it's got quizzes, it's got everything you'd expect from a course. Someone asked, which Coursera course? Let me go ahead and post that there
Yeah.
for you. Follow it again.
You should also tell them about developer hours and drop a link to that. So we do this thing called developer hours every Tuesday at 11 a.m. Central Time, which is 12 p.m. Eastern and 9 a.m. Pacific. It's hosted on Zoom, and you can drop in, ask questions. It could be general, related to anything visual AI, or like specific 51 issues that you're dealing with as well. So great resource, great way to get help as well. All right, cool. Thank you guys for joining. Hopefully, if you guys are in any of the places that we are hosting a event in person, hopefully you are able to attend one of those events. Yeah, so let me give you that link real quick. Give me 1 second. The developer hour link, there's like a registration form for it. I just gotta find it. Well, how about this? Yeah, join the Discord community. The announcements go there. I don't know where the Discord, sorry, the Zoom sign up is for that developer hour right now. Oh yeah, maybe Jimmy had linked it. I'm not sure. Yeah, there you go, right there. There's a registration for it. All right, cool. Well, take care, everybody. We'll see you around, and hopefully in the Discord channel server. So if you're there, come say hi. And yeah, best luck in getting started with 51. And we're here to help you as you progress along your 51 journey. So cheers, everybody. Take care. Have a good day.